Hi, and thanks for joining me here in my shop on what is bound to be the first really hot and humid day this year so far. So while I'm down here in the shop, what I'm going to focus on today is, of course, the IF transformer I removed yesterday. And what we want to do here, first thing is take a really close look at it. And then the second thing is perform some tests on it before doing anything to it. And then we can start fiddling around with the slug positions. Hey. What happened to the slug? Oh my gosh, it stayed behind in the can. I didn't even know that. Wow, okay. That's a little unexpected. We'll worry about that in a moment. But certainly the slug is now in its extreme position to start with, that's for sure. So let's take a close look. I have my camera here. We can look closely with this, and then I have a microscope set up. We can look even closer. What we want to look at is a couple of things. The wires coming down from the coils and all that stuff. We'll just take a look at it. But the main thing is the little capacitors that are tucked away inside there. That's really what we want to look at. So we'll start with this camera here. Okay, let's take a look here. So one of these is the primary, of course, and one is the secondary. And primary was the one with the slug coming from underneath the set, I believe. That's interesting there. So I see this line in the wax, this line here, and it sure looks like that wire was once in there and got tugged out. Well, we'll tug it out. You know, there's a lot of dust in here. I'm a little surprised there's this much dust. But of course there is a high voltage in this, a B+ voltage in this can on one of these two coils. The primary one would be this one. And that should, you know, potentially attract the dirt. I don't know how's so much dirt. It's only a little hole, you know, exposed. And look at how much dirt got in there. So, you know, just so you can see the two capacitors there. Of course, they've got lots of dirt on them. And they're not going to be physically disturbed. They're so protected inside this can. Sorry for my camera work here. Look at those wire leads. We're going to look at this with a microscope. So the construction of this capacitor, I believe, could be wrong about this. The brass outer plate is one of the plates, and then inside is it looks like a copper piece going right through it. Do you know what? I don't know if that's quite correct. How they're done. Maybe we look with the microscope. We'll see better. So nothing's really leaping out here except it's dirty. Let me flip it over. Look at the other capacitor. My guess is if there's trouble, it's on the primary with the capacitor. It's on the primary side, but I'm just guessing. So this capacitor doesn't seem to be quite as dirty as the other one. So you know, maybe this is the secondary side. There's no voltage involved. So let's see. The wire goes up. It comes back. Oh, it looks like this is connected to the primary side. the lower coil. Curious about that blob on the wire there. This is very special wire, and these are very special windings. You can see how they're not just ordinary windings. What's that black? Oh, that's the space between them. Some kind of compound down in there. Okay, let's look under the microscope, because this isn't revealing anything spectacular yet. I don't really expect a spectacular revelation to come from this, but I just want to be... Again, one thing that I think is possible is cleaning this may have an effect on it. So maybe the capacitors interfered with some amount of dirt or something like that. I mean, moisture would be even more likely. There's a good shot right of the edge of the capacitor here. So this is a little hard to make out, but the silvery part here, up here, is the terminal, the silvery part. I'm not sure what I'm seeing. I mean, I think I know what I'm seeing, but I don't understand how it could look like that. Let me rotate this a little bit. Maybe we're getting a strange view of it. So I'm trying to assess if there's in any way enough dirt here to justify a problem. And I don't know. You gotta imagine the other transformer looks the same as this one. Let's see if we can get right in on that edge there. There's something, you can kind of see the layers in the capacitor right in that corner. How am I going to hold this way? I need my spare hands. Let's bring them up here. Okay, I think that's a good angle right there. Let's see what this looks like. Okay, it's just about the spot I'm after. See if I can get this to focus. And the wire is right in the way. There. And we're looking right in the edge of the capacitor. We're trying to anyway. Well, maybe I can get it just a little better focused here than it is. Well, it looks like two metal plates separated by something, and then they're clamped over by this larger piece of metal, which looks, you can see it's, you know, the outside metal clamped around. So it looks like two plates separated by an electrolyte, but how in heaven's name do you clamp it to like with a big piece of metal around the outside? So I don't understand how these are constructed exactly. Got a number on it. It's 51. I don't know what that is. So, question is, can we bring these guys back? Is this really the problem? You know, I have found these in under chassis. I don't go looking in people's IF cans too much. So exactly what's in them. But you know, this certainly looks like a troublesome arrangement with this open capacitor. Let's take a look at the wire here. The wire is probably quite special. So can you see that there are strands in the wire? This is a really thin piece of wire, but it's actually made of strands of wire. There's a good chance they are individually insulated with, you know, something, not paint, but you know what it is. So that little wire there, and then in the actual coil, you see it's very complicated how they wound it. It's got twists and turns in it. This is all to control stray capacitance and things of this sort, skin effect, other unwanted things that occur that reduce the Q of the coil, the Q of the circuit. They want the highest Q possible, I would think. Q stands for quality, and it's basically how resonant this thing is, how much resistance it has in it, stuff like that. Well, I think we could look at this all day. I'm not sure I'm going to see anything. So now if I'm going to clean this, what would I do? Vacuum it, blow on it, soak it in solvent. Those are my options. Vacuum it sounds good. First we got to get it tested. We got to set this thing up in a test jig and go at it there. You see why hand, like me rewinding one of these coils in the shop here, I mean I could never achieve this, and that's impossible. One wire, what's it doing? These coils are far from perfect. It looks like there's a wire just... And the chances of me spotting a wire problem here is like nil. What is that? I'm going to do the stupid thing and poke at it. If this coil was open, the radio would not work. Oh look, I can see where it's going. It's just going along up to here. Okay, I'm not going to worry about that. I'm sure there's a little bit of sloppiness in some of these coils. Seen enough? I've seen enough. I've seen enough. I have seen the light. Okay, so the next thing I'm going to do then, I'm going to set this up so we can run a sweep generator test through it, fiddle around with it, put the slug back in it, because it's not going to work well without its slug. not expect that to happen. So how in the heck do you? So yeah, right. So clearly you can't be tuning this guy up outside of the radio and then stick him in because of this problem right here. I'm not sure you could do that anyway. You can tune one of these guys outside the radio and then solder it all up and it'll be okay. Come on, drop it. There he is. Well, that means this upper slug is completely uncontrolled until you put the can on. Of course, the can probably has some influence on these coils anyway. The can is made of tin, I'm pretty sure, but it may still have some bearing. Could be tin-plated steel for all I know. Well, this will be fun. This will be fun doing this. Okay, let me get her all wired up here. Okay, so I got my scope on camera there, and if I turn on my sweep generator, start sweeping, you see something going across there, and you see some curious stuff on it. So let me show you what is going on here. The sweep, by the way, is set to go from 400 kilohertz here up to 500 kilohertz here, and not quite in the middle would be 455. Now, right now this coil, when it was in the radio, seemed to be tuned somewhere down here instead of up here where it should be. So I haven't got the signal level turned up yet going into it. So we're looking at the output of the secondary of the coil. So let's take a look at the setup here. Something too complicated. Oh, I don't have my scope hooked up. That would explain something. Okay, scope is on there. Let's just... Oop, wrong one. Let's just make this a little bit less sensitive. There we are. Let me check a few things here. Okay, so I want this to be centered as best as possible. So, 450 is going to be in the middle or close to it. I think we're all set. So I've just put the slug in here kind of in a random position. Look at that. There's a resonance there right now. The sweep generator is, as I said, going from 400. So, well, that's not supposed to look like that. That's not supposed to look like that. It's supposed to have a peak on it. Why does it look like that? Okay, so it could be I got something all messed up here. I've got almost no input signal. So something's got to be messed up here. See a shape there. Let me move that slug around a bit. Oh, look at this. My hand's close to it. Touching the slug thing. I get some interesting shapes on the scope. Swoosh. Fingers on it. Yeah, with my fingers on it, the situation's quite different. And probably shooting a pile of noise into this coil from my fingers through capacitive interactions and stuff. Okay, enough fooling there. Now, why aren't we getting a nice clean peak here on this? What is going wrong? Got capacitor here and a capacitor here. I have these two terminals across the capacitor, so these got to be coil terminals. That's how they're labeled in the manual. So this is the input side. It's going to the lower coil. This is the primary coil operated by the slug on the bottom. according to the manual. Then the output's going to come out of the secondary coil across this other capacitor and go out these leads. Why would that not make a nice picture on my scope? The resonant point is way far away from where I think it is. I'm sweeping in, I'm not even sweeping through the resonant point. Well, that doesn't match with how it operated in the radio. It could be hooking up all this stuff, these wires, their own impedance, all that kind of stuff, throw this whole thing off, maybe. But I had fooled around with another one of these, a much simpler one from a 5-tube radio some time ago, and I found I could set it to resonate right on 455 as if it was still in the radio. So why not this one? So what I'll do is I'll change the sweep to sweep a much larger range. And okay, so here's what we'll do. We'll stop the sweep. We'll lower the starting point from 400. Take it down to 300 basically, and we'll make the stopping point, instead of 500. What was that? Instead of 500, that was my scope popping off. 500. Make this 600. 600. What did I do? Just bear with me here. Well, that's close enough to 600. So now it's sweeping a much bigger range. Let's make it sweep. Make it sweep. So now we're looking at 300 to 600. Looks totally different. Definitely sweeping. Okay, let's jam in some signal here. There we go. Now we see a little bit. But that's really not a... It looks like a snake biting its tail. How does that happen? Okay, let's fiddle with this. That's very interesting. It's certainly moving it around frequency-wise, isn't it? Turn this other one. This is not at all the shape I expect here. Of course, I can only move this slowly. Does anybody see anything happening there? I don't see anything happening. Maybe. This is where you need to put a meter on, an indicating meter. Well, that is the weirdest looking thing on the scope there. What is happening? So this really changes the frequency of whatever the heck that is. You can see where I get right out of the coil there. Probably start getting close to the next coil. It's quite a range. This primary one doesn't seem to do much. Oh my god, the scope is disconnected. You goof. Okay, once again, Jim, you're goofing up big time here. I even knew that was off. Well, that's a little different. Okay, now we're in business. We finally got there after some goofiness. Okay, well, why is it way off to the left? Remember, that is the problem with this, isn't it? Okay, so let's try this one first. This is easy. Oh my gosh, that's a fantastic curve now. Shrink it down even more. That's fantastic. Get it in the middle. It's got to go in the middle. There it is. That's what I'm looking for. That guy there. Quickly to the middle. Okay, so if I can tune this out of the radio to 455, I'm going to have to go somewhere and ponder what's going on now. I'm turning this and it doesn't seem to be moving. How can that be? So I'm goofing up on a major scale here of some sort. This slug is now out. Well, we're not getting anywhere near 4, assuming 455 is still in the middle. I believe it is. 450 anyway. So what are we finding out here? We're finding out something's going on. Has the slug separated from the shaft here, and it's just sitting in one spot inside, and I'm not moving it as I turn this? Interesting question. I should be able to hit it with the other slug or some other tool. Yeah, that's not long enough. Let's go down there and give it a whack. Now, chances of it having come disconnected, I got a fat chance on that happening, but let's find out. Oh, it will push upon it here. Make it better. There, I think that's a little better. No, it's not going anywhere. So what's happening here? That this is not changing the resonant point. The capacitor is completely shot. The capacitor is, well, let's go through them. First of all, the capacitor is open. There's no capacitance whatsoever. The coil would have some kind of resonance against some kind of capacitance from whatever, from wires, from whatever. And so it would be some resonant point somewhere. But it might be miles away from where we are now. That's number one. Number two, the capacitor is shorted right out. So there's no signal going through the coil. I can't imagine we would see this coming out of the secondary then. Isn't that interesting? Look at this. Size, frequency. That's the opposite of what I thought. I thought the primary coil, this is my experience, okay? I haven't read this or anything. The primary coil kind of set the frequency, and the secondary coil you matched it. But this looks very different. Shifting ever so slightly in frequency here, but quite a bit here. It could just be the fact that whatever's wrong with this, if there is something wrong, is why it's doing that and not doing the same thing as this one. So what are we going to do now? I'm not comfortable. I am not comfortable. I don't have a feel for what has happened here. We have it right out. We have all the wires off of it. Let's let us do this. We have all the wires off it now. Let's see what this guy has to say about the situation. Uh, 2.5 millihenries, 11 ohms. So that's basically the very same reading I got previously. Now that should have been that's the primary coil. Now the secondary side. So these are supposed to test at 15 ohms. Oh, what happened there? .17 millihenries, 12.5 ohms. I think that's pretty much the same. Let me stick the slug right in the coil here. 1.17. Let's see what it is now. 2.39. Well, this is, you know, as usual. The results are not what I expected, and leaves me just a little bit unnerved here. What else could we do to this thing? Tilt my head take the other one out and compare it. Yeah, sure. So this is definitely the input going on the primary. Scope here. The secondary. How are we going to get that in the middle? So, okay, normally this is in here. Let's make things a little normal. Oh, I pushed it way off. That's interesting in itself. I'm absolutely sure that I've got the scan rate set right. Let's check. So this is the start frequency, 300 kilohertz. The stop frequency, 600. So 300 to 600. Letter sweep. There it is, way over there. It's below 300. Below 300 when I put the slug in its normal position. So you might be saying, well, you just can't test it this way. It just can't be done like this. I've got 50 ohm leads here, 50 ohm test equipment. I am using this guy here. He has a little choice here about input impedance. Didn't that make a difference? I'm on the times 10 scale. These leads were just throwing that off that far. That would not surprise me. Okay, so what happens now when we move this one? Okay, we still get that effect. That's cool. And the other one. Whoa. Is it just me? It's really not going anywhere. So how can you move a slug through a coil in a resonant circuit and have it do absolutely nothing? So the coil can't be open. We just measured its resistance. The resistance was a little low. Supposedly 15 in the manual, 11 in the measurement. Chances of there being shorted turns, there would be evidence of it overheating, wouldn't there? Wouldn't there be, if a heavy plate current flowed through here and caused damage to it, it wouldn't necessarily be visible. I think the two coils would have some difference of look. Some of the liquid would have flowed out of this one, or it may turn dark. This problem may have been in the radio for hours and hours of operation. The temperature may have come up just to the breaking point, and then finally did break. I can work this coil mechanically. I can twist it, squeeze it, and see what happens. What would happen if there's an open in the coil and I manage to close it? Then the resonant point would leap on the scope. Just wiggling and moving around won't mean much of anything. Just mean my fingers are on it. I give this a minus 5% chance of working. So we're looking for a sudden jump. Meanwhile, I'm running the risk of introducing a fault. Okay, what about touching some stuff here? So that's the inputs. That's the outputs. Oh. Doesn't that knock it? Knock it down. So am I seeing that this coil, it resonates fine? That's why this happens. It's sure, boy, that's pretty hard not to believe that. And the other one just seems to have no resonance to it. Now, how does that match up with when it was in the radio? In the radio, I couldn't reach the resonant point because look at the resonant point. Way down here, right in here. You know what? I think that's almost the same spot. Well, that's close to 300 now. I just couldn't get there before, so I was stuck up here somewhere. So we assume the lower coil is, the primary coil is way off. Now, way off comes from bad capacitor, I think. So how big are these capacitors supposed to be in there? They are supposed to be 56 and 56. This is the second one. Over here, they're different. They are 100 and 100. 56, so remember I could see the number 5 on one of them, so that all adds up. So is it 56? How can we find out? It's got this silly coil across it. Well, the coil leads can be removed from a terminal fairly easily, and then that leaves just the capacitor. Fairly easily is, yeah, who wants to fool with that? Eventually, if I'm certainly on my, I'm pretty certainly on my way to changing these capacitors here. So I could at this point just cut them out, put in 256, and see what happens. Cut one out. I can cut one lead, free it, temporarily put in a 56 and see what happens. I could then bend it back and resolder it if I really wanted to. Maybe. Okay, so the primary side, we are pretty sure could be fooled here. Yeah, fooled is right. Yeah, this lead goes to here. Primary side capacitor. Nip that guy. Wow, you can't really nip them. The tab is laid up against the terminal and soldered in. So I'd have to sort of heat up the terminal here and then push the capacitor off of it, like that. I'll probably leave the wire just fine here. Now there's no clearance to push the capacitor because the capacitor's up against the tube. I can push on it all I like, it won't come off. So really I have to pull this away. If I pull this away, the capacitor will probably come with it. Bend it ahead of time, give some clearance. Oh, I don't like doing these things. See, I'm not using a tool, so I really feel the strain. So I can see clearance now behind the capacitor, a little bit. Let's go just a little bit further. If I bend this out far enough, it's going to rub up against the can. Oh, that's scary. Okay. Capacitor's clear from the tube now. Put some heat on there, push the capacitor. Oh, well, let's take a close look and see if that's really true. Is that really how that's done? Or the next thing you know, I'm going to be singing the blues here. I'm not a good singer. You don't want to hear me sing the blues. So we're trying to look right at this terminal. Here it is, right here. Give us a light. Focus up and down. You can't see how it's hooked up under this angle. Pretty sure I'm right though. It's just sweated up onto this terminal. Without realizing it, you can see it in that microscope view. But the only reason I can recognize it is because I looked with my own eyes. Okay, we're going to try that. We'll see what happens here. So heat them up and then push them. Actually, pry them apart would be much better. Pry them apart. That would be a better way to do it. So I gotta get in behind here. That's it. That's the spot. There's a fair bit of metal here to heat up. Let's help it out. Oh, jeez, I just stuck my finger right on that. Lucky I didn't get burned bad there. Dripping solder. I'm on the turntable. It's turning. Don't turn, turntable. Oh, this is not going to go well. I just have to melt the whole thing off here. Patience. Have some patience. This has really got the wrong tip on it here. I'm just not getting enough heat conduction. Come on, man. So I haven't been able to calibrate this tip, and I don't really know for sure what its temperature is. I've got it set to 355. Okay, it's all melted up. Everything is sizzling. Everything is sizzling here. Come on apart. Misinterpreted this? No, I haven't. Come on, you can do it. Right apart. It's stuck together here somehow. How have they done this? Why didn't it come right apart? No clearance. It's a clearance issue. No clearance. Okay, push harder. Doesn't want to come. Okay, hold it. Let's not get too carried away here. Now, I've heated the heck up out of that capacitor. What happened on the... So I'm looking at the scope. It's in the middle. It's moving a little bit. Okay, have I gone crazy here? It's still maxing out way over here. Okay. So just wondering if all that activity had somehow solved whatever the problem is. So I think I got to get in there and just cut that guy away. I can't quite see how it's holding on. Not by much. There we go. So hopefully we haven't cut the wire to the coil, just the capacitor. Looks like I've achieved clearance there. What happened on the scope? Hey, not much happened. I've loosened up this terminal quite a bit, playing with it. But it's tapped the capacitors out of the circuit. And it didn't make much difference, did it? Pretty useless capacitor. I will now get a 56 out of here. Let's look for 56. Gotta be exact. Exactly 56. We could use 56. 56. Right on the money. 55, 56. Try to touch this. I can be clever here if I just bend this the right way. Grippy things. That might not be good. Yeah, I think I did that way too much. Ooh. Catch those wires. Good show. Now, breaking it off. There we are. Okay, did it make a connection there? I don't know. Anybody look at the scope? I didn't. Uh-oh. That's not so good. Still nothing happening. Cutting away the capacitor and making no difference. How can that indicate a problem in the coil? Doesn't that just prove it's in the capacitor? I just did all that and nothing happened on the scope. I mean, come on. Why? Am I doing something stupid again? Let's see. So I'm on the primary side. I've removed this capacitor. Let's test the capacitor. We can test it now. Yeah, out of the circuit. That's the thing to do. Right on. Okay, little capacitor. Ready for a surprise? Taking his time. Something up. Instead of 56, it's 47. So V loss 0. So it's not way out. It's not way out, and I've just added another one. This is not going the way I wanted it to, for sure. This is not going. Well, with the capacitor disconnected, we can read the resistance of the coil very accurately now, and its inductance. So we'll go on there. Here. Oh, what happened? How come it came to life like that? VCC, what's it doing here? Gee, something funny happened. What happened to my machine? It did a funny flick there. Did anybody see that? Oh, what's all that? Short probes. Short probes. What's going on? I've never had the meter ask me to do this before. Short probes. So what are you supposed to do? T1 reference. What is this meter doing? It's just doing its own thing now. T2. T3. Isolate probe. Which probe? Isolate the probes? Isolate them all? Isolate probe. I had no room for the S. Isolate probes. What is this guy doing? Well, I have a meter here that's just gone off into Never Never Land. CO 3940, 35 picofarad. What is this thing doing? Must be in some kind of weird test mode. 0 nanofarads. Well, I got nothing hooked up. Are you done? Are you ready? What should I do? Should I push the button? Oh, such fun. Test end. Version 1.12k. That's some kind of self-test it just did. Version 1.12k. I think it just did some kind of self-testing thing. That ended up with the OK. There we go. It's working again. Okay, so I got, okay, so who knows what happened there. That was quite an interesting little journey. So we want to test the coil. The coil is still connected to the leads. Oh, look at that. As soon as I touched it here. Oh, you know what? You know what I'm doing? You know what I'm doing? I'm a dummy. Okay, who saw that? I still had the input signal on it. So, okay. This will probably work better. I think this meter generates its own test signals, various frequencies and stuff. It does a little routine thing, I think. So maybe without the signal there, it was just blowing its mind. Hopefully it didn't blow it permanently. 11 ohms, same reading. 2.35 millihenries, same reading. Now we get 2.35 millihenries on this side. We get a similar amount on the other side. So what's the issue? 11 ohms. 11 ohms. Okay, so, you know, the manual does say 15. It's measuring 11. The other one measures 12 and a half. Shorted turns. Shorter turns results in less inductance. Less inductance would mean you need less capacitance to get to where you want to go. Can I stick a capacitance box on here and flip it around a bit? I don't think I've got one that'll go down to those low amounts. 0.0 is it not? Yeah, 0.0001. That's 100. No, it's nowhere near it. No, I don't have a decade box that's going to get in that range. So we'll take a guess. If there's less inductance, you need less capacitance. 56. Wow, let's just take a wild guess. What's half of 56? It would be 28. So we try a 28 or something in that range. How about this? How about a 22? So maybe we can find a capacitor that'll make it resonate properly. We don't need this one. I need to touch this lead here. Hey, where's our scope? Oh yeah, I disconnected the scope. Oh, boom, 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 boom. We need the signal. Bring on the signal. Okay, there we are, back to the same thing. Now, didn't I find putting the capacitor on made no difference? Isn't that what I found? That's what I found. Found it again. Let's go back to the slug stuck in here. Slug is stuck. When I banged it from the top, it didn't move because it's stuck. You turn this thing all you like, it doesn't move it. should be able to see or feel it moving it. Look at this. I'm pretty sure this is embedded right in the slug. This is rugged. Some of these are not rugged. This is quite rugged. You could take quite a bit of abuse. Chances are really small that the slug doesn't move. Okay, I think I can be able to feel any movement with my fingers. And I don't mean rotational movement, I mean sliding in and out. If I just do it like this, I use my fingers. Oh, it's definitely turning in there. No doubt about that. Yeah, it's moving. Oops. Yeah, there's no question. Slug is moving. I never did try cleaning this thing up, but I can't imagine. Did I not get this separated here? So what am I proving? I'm proving the capacitor is okay, the coil's okay, everything's okay, nothing's okay at the same time. Okay, if you're saying Jim's gotten desperate, yeah, you're right. Well, I'm gonna have to stop at this point and ponder the situation, because this is like an unexpected result. Probably a result of how I'm doing the test. And what is the result? The result is I can't seem to make any variation on the primary coil of any sort. Move the slug, change the capacitors. It just is what it is all the time. What is that telling me? Yeah, I don't know. I think I gotta stop at this point and go away and wonder, because I'm exhausted for ideas here on what to try next. Okay, it's a beautiful day outside again today, so that's where I'm heading. Thanks so much for watching, and we'll have to carry on tomorrow, I guess. See ya.